So I am here to talk about some of the research works that are going on in IIT Kharagpur. In fact, since the time is short, I shall be concentrating on one of the works. Now, I am happy to say that at IIT Kharagpur we have the largest group of researchers, including faculty, students combined, in India, who are working together in various areas of security and security. I am also a member of that group, and as per my current activities, apart from other areas, I am also working in some areas related to hardware security. So I thought, so why don't I talk about one of the very important areas that have drawn the attention of researchers and other practitioners in the area of security. This is the topic of my talk, hardware Trojans. Solutions to this problem is still not matured enough, but people have been researching hard because they suspect that this is a serious security threat that may have already affected us, many of us. So let's just try to understand, for the benefit of those who are not that much aware of what a hardware Trojan is, so exactly what this is all about. So I shall be basically talking about the various types of Trojans and some of the Trojan detection techniques. Well, I have several slides in my presentation. I shall not be spending much time on some of them, but rather I would like to explain to you exactly what the problems are. Now, I believe all of you have some idea regarding the IC manufacturing process. Whenever we design a VLSI chip today, we use the CAD tools and we rely on many parties in the process. This is a simplified diagram starting from the specification to the design, to the interface with the fabrication facility, down to the creation of the mask. Then after the VLSI chip gets fabricated, you do something called wafer probe, dicing, packaging. Then after packaging, you will do the testing, and so on. There are many steps involved. And during the design of the chip, we normally use some standard CAD tools for that. Okay? Synopsys, Cadence, many tools are there. So we typically use something called IP cores, intellectual property cores, which are some pre-designed blocks or circuit modules which have been designed by someone else. So we can lease or we can hire that design for our purpose. So we can take those IPs, and there are some tools available. There are some standard libraries from where you can pick up components like standard cells, and various models exist. Now in this diagram, what I want to tell you is that the blocks which are marked as green, specifications, package testing, deploying and monitoring, these are something which myself as a designer are doing. That's why I say that these are trusted steps in my whole design cycle. The ones which are marked as yellow, we are not really sure about. So we are relying on some third party for like that IP, intellectual property design codes, that I am taking from someone else. The CAD tools, I am buying the tools from Cadence or Synopsys, for example. So I really do not know what is there inside the tool, whether there is or there is not any kind of malicious code inserted in the tool. So I am not sure about that. Similarly, you look at the fab. I sent my design out to a fab. My chip gets fabricated and comes back to me. So what is happening is in the fab is a black box to me. I really do not know. So whether they are fabricating exactly what I have asked them to do, or they are fabricating something more beyond what I have asked, I do not know. And the ones which are red, particularly these red to the fab, these are absolutely untrusted. Okay? These we really cannot trust. So the idea I want to give you is that I create a design specification. From the specification I create a design. I get my chip fabricated and I use the chip in some very high security applications. So I build a box which is being used in high security applications. But I am not sure whether that chip has some malicious hardware components installed or built into it. This is what we mean by hardware Trojan. So this is something which I have already talked about. So because of the intellectual property based designs, using CAD tools from various vendors. So as a designer, I am not directly interfacing with the fab. I create the design in some standard format. I send that standard format in soft copy to the fab, they get it fabricated. So there is a partial loss of control during the design and the manufacturing phase. And there are, as I said, a number of parties. So all of them are or may not be totally trustworthy who are getting involved. Okay? So specifically hardware Trojans are some malicious hardware elements that somehow get added to my design. Now this can happen either during the design phase before the manufacturing has started, or maybe during the time I have sent my design or my specification to the fab for doing the actual fabrication. So it can happen in any step. Well, means whatever happens at whatever step I do not know, but something unintentional gets added to my design. Because of that, well, my circuit can start malfunctioning any time, depending on whatever the malicious party wants it to work like. Like I can share one small story with you. Well, the story was shared by me by an army general long time back, about 10-12 years back. So he said that, well, we have a number of artillery equipments. They work perfectly well in field while we do the testing. But what we found to be very surprising is that there was some kind of emergency situation when we actually wanted to use those equipments. But to our surprise, we found that all those equipments got locked simultaneously. None of them were able to fire anything. So they were suspecting, so do we, that there were some malicious components in those systems built in. Maybe in the embedded systems, maybe in the chips which go in there. We really do not know. Maybe someone else remotely are controlling those systems because of that. The consequences can be very far-reaching. So this is an important question, whether Trojans do exist today. So no concrete proof has been demonstrated by anybody, but there are symptoms, a large number of symptoms which people have found out, which may possibly taking place because of the existence of something similar to hardware Trojans. See, we buy network switches from China. They are very cheap as compared to the competitors. But we do not know what is there inside. Well, as a network switch, they are working fine. But beyond that, what extra things they are doing? There are also some reverse engineering tools that are already available. People do use it. So using reverse engineering, you can possibly have a mechanism to analyze a given design, to add some Trojan or malicious elements to a design and so on. Tampering at the design stage is also not impossible. They are in fact quite easy. So these are some examples which were cited in some journals or some magazines. Some events where people felt that this may have happened possibly due to the presence of a Trojan, but there is no 100% guarantee. There is no proof. The trouble is that detecting a Trojan is not so easy, and we shall very quickly go through some of them. Now, talking about the different kinds of Trojans, well, we are specifically talking about hardware Trojans in this lecture today. So you can have a combinational Trojan, sequential Trojans, depending on physical activation and action attributes. That is how the Trojan looks like, it's the physical attribute. So on what basis the Trojan gets activated? It is the activation attribute. And after activation, what kind of malicious activity it is trying to do? That is the action attribute. So depending on these three things, we can have a variety of Trojans, Trojan types. So simpler way to classify is a trigger and a payload. Trigger is something like activation. So what is the event which triggers a given Trojan, and payload is what happens when the triggering happens, when the Trojan gets activated. Talking about digital Trojans, so I am showing some very simple example because it is difficult to discuss more complex designs here. You see, this is a simple circuit consists of 3 gates. The uppermost AND gate, that is the correct version of the circuit, let's say. And the circuit which is within the dotted portion, that is the malicious addition which has taken place. So depending on a particular condition, when both A and B, both of them are zeros, then only the output of the NOR gate will become 1. And then only what will happen, the output of that gate will get inverted because of the exclusive OR. One of the input is becoming 1. So normal condition it is fine. When some particular inputs are coming, then the output is getting modified. So this is a very simple example I am taking. But in general, you can extend this concept to any kind of complex scenario. Similarly, you can have something called sequential time bomb, they are called. Sequential Trojan is something where some circuit is continuously running with time. So whenever some pattern appears typically in a register, there is a clock coming, you really do not know when that pattern will come. That can be a simple counter. If it is a counter, then maybe the person who have inserted the Trojan have designed it in such a way that whenever, let's take an example, 10,000 clock pulses come, then the Trojan will be triggered. That is a fixed thing. There can be other scenarios where you have some randomization in the circuit. Some pseudo-random number generator are there built into the circuit. Some random numbers are generated, and from that random numbers that are getting generated, some registers or counters are getting activated. Then again similarly, so whenever some special or specific patterns are coming, then the Trojan gets triggered or detected. So hybrid Trojan is a mixture of combination and sequential. Now analog Trojans also exist in terms of nomenclature. They are, instead of talking about digital gates, we talk about voltages. So there are various ways to introduce analog payloads. Basically we are trying to modify the voltages and currents in a circuit. That is analogous to changing the behavior. There are some very interesting kind of Trojans which also have been talked about. These are called information leakage Trojans. Like you think of a cryptographic chip that many of us use in many high security equipments. Suppose I have an AES encryptor, encrypted using AES algorithm. Now some malicious party during the design or implementation of the chip, what they have done, they have added some additional circuitry that is marked as yellow in the lower diagram on the right, some additional circuitry. So what it is doing, you see, for those of you who have some knowledge about the process of attacking cryptographic algorithms, you will be knowing that if the intermediate results of computation, say AES algorithm for example, works in several rounds. Let's say there will be 10 rounds. Now if the output of each of the 10 rounds is made available to you, then you are in a much better position to try and attack AES and try to break it. Now that additional circuit, what it does, it generates a pseudo-random number which the attacker knows that what kind of pseudo-random numbers have been generated. And from those intermediate values, from the registers, it does some kind of XOR or some operation, and it generates some noise signal from there. You see, there is something called side channel attacks or side channel analysis. This is a very common method today of trying to attack cryptographic implementations. Suppose I have a box which computes some cryptographic operation, maybe encryption, decryption, let's say. So if I make some measurement externally while the device is carrying out the operation, say I am measuring the current drawn by the device, or I am measuring the electromagnetic radiation which is emanated by the device, or I am measuring the variation in the temperature. There are many such parameters which are called side channels. Some information gets leaked out via those side channels, and through those analysis it is possible to get the values of those intermediate stage data. Now, in our lab, for example, we have been able to successfully attack and break almost all the existing cryptographic algorithms. Like we have broken DES, triple DES, AES, several stream ciphers, RSA also. So using these kind of attacks, we have broken just by measuring the current and electromagnetic radiation. We have been able to break. So such technologies exist. So if someone intentionally inserts such a Trojan in your chip becomes very much vulnerable to side channel analysis. So, well, Trojan detection technique, unfortunately, it is in a very immature stage. There are a lot of researchers who are working on that, and most of the works which have been reported on that, they try to detect very specific kind of Trojans. Like I may have a method which will work only when one particular Trojan is present in a design, but it will not be able to detect other kinds. These methods, it is very difficult to have some kind of a formal verification of this method. That means you really cannot have a formal proof that these methods really work. But you can validate, or you can try to increase your confidence in the working of these methods by using some computer simulations. You try to insert some Trojans through simulation in the simulation model, simulate the circuit and compare the behavior and see that whether you are able to detect the Trojan or not. Trojan detection is challenging because of number of reasons. Like I mentioned one or two of them already. Like broadly speaking, these methods can be either invasive or non-invasive. Invasive means you have a circuit, you break open the circuit, take it to a lab, see what is there inside. But it is an irreversible process. Once you break the circuit, you cannot get it back in the original shape again. So most of the methods that people feel practical will be non-invasive techniques. And another property that most of the Trojans have, like the types of Trojans which have been reported by various researchers and experimenters, that the nodes in a circuit, you try to insert Trojan in a node. Now, typically the level of activity in that node is very less, because if the Trojan gets activated very frequently, then it is rather easier to detect the Trojan. But the more dangerous types of Trojans are those which are hiding in a stealthy way somewhere, and very rarely sometimes it comes up and does something very malicious. So typically most of the Trojans are like that. They will be sitting on lines where the activity is very low, they will get activated very rarely, and also the payload nodes. Payload means the places where the Trojan is actually hiding. They are very difficult to observe from outside, whatever is happening here. That is meant by low observability. So the circuits are usually designed in that way. And side channel analysis that I just mentioned, well, there are scopes for using side channel analysis for detecting Trojan, but there is one catch. You need to have a golden circuit available to you, which is a version which is free from Trojan. Then you can compare the two. You can do side channel analysis on both versions and see that there is a difference. But unfortunately, for most practical cases, we do not have that golden version. Like here, for example, preventing free dead space. Like you see, normally what happens when I design a VLSI chip, there are, suppose the fab where I am sending my design for fabrication, it supports a particular area of the wafer where I can put my chip. But it may so happen my design is such that I am not using up the whole area. There is some area which is called so-called dead space, that is empty. So the fab person, if he or she is malicious, can try to insert some additional circuit in that dead space, make some interconnections with existing circuit through some kind of reverse engineering, so that the Trojan can get insert. It is not easy, but it is certainly possible. So obfuscation of circuit functionality is another method. So means this, if we have actually demonstrated. We had shown synopsis that, well, you have your tool, we have modified one module of your tool, and you see that whatever netlist you are getting is an obfuscated tool. So not only the design that I am wanting to get is being synthesized, but also some modifications. So it is feasible. We have done a feasibility study, we have shown synopsis that, well, you need to do something so that such things can be detected automatically, but of course it is very difficult. Assistive techniques is that, well, there can be some special mode of operation of the circuit, and once the circuit works in that particular mode, detection of the Trojan may become easier. So when I design my circuit, I keep some special modes of operation. During the special modes of operation, if the Trojan tries to wake up, it will be much easier to design. This is the basic philosophy. Well, and this is one interesting slide I want to tell you. This is something which some of our colleagues have done. So some kind of a design flow automation has been proposed where some Trojan can get inserted or can be inserted in a design. Well, this we have done for two reasons. Firstly, to demonstrate that it is not difficult to insert a Trojan in a design. Secondly, to come up with some kind of a preventive measure, like my Trojan can try to detect and kill another Trojan which is trying to get inserted in my design. So a Trojan versus another Trojan, something like that. As I said, at IIT Kharagpur we have not less than 12 or 13 faculty members who are working in the area of various aspects of security. Some are working in network security, cloud security, the areas where most of you are interested in. Some of them work in the area of cryptography, cryptanalysis, then there is hardware-based security, hardware-based protections, and so on. So under general security, there are many works which have been proposed. I have listed a few of them. Security policy integration in cloud-based collaboration through selection of trustworthy provider and permission authorization. This is a project which has been sponsored or funded by an industrial organization. So this is a funded project. Then trust-based security access control models for managed and formal analysis of security policy implementations in enterprise networks, digital rights management using something called reversible watermarking. These are some of the works that are going on in general security. And in the area of cryptography, there are various areas where research is going on. Like we are developing new ciphers, new block ciphers, new string ciphers for various kinds of applications. Like ISRO has given us some specifications for the satellites. They need some very high-speed cryptographic operations which will be operating online with image captures and data transfer. lightweight crypto algorithms for various applications, starting from RFID to mobile devices. And a very interesting new area of research has come up, where also we are doing some very good work, that of designing physically unclonable functions, or PUF. So it has been proved that once you have the capability of building a PUF, some function in hardware which cannot be cloned, they will all be retaining their unique individual signatures. So once you are able to design and implement a PUF, you can develop lightweight cryptographic algorithms which will be very simple. So we have been able to come up with various PUF architectures, and some of them as proofs of concepts. We have also implemented on FPGAs to demonstrate that it is very possible. And of course, malicious hardware and mitigations. So I think it's a very short summary. So
thank you so much.